Astronomers around the world are completely baffled after detecting a mysterious signal coming from Proxima B, a nearby exoplanet that could support life. The transmission, incredibly precise and focused on a single frequency, is far too perfect to be natural. Could this be humanity's first real contact with an alien civilization? The discovery began like so many others. A late-night data sweep. A tired astronomer blinking at columns of numbers. At the Parkes Observatory in Australia, something odd appeared on the readout. A sudden spike, razor-thin, perfectly steady, fixed at 982 megahertz. At first, no one paid much attention. Cosmic noise is everywhere, and most signals vanish in seconds. But this one didn't fade. It returned night after night, unwavering, like a heartbeat pulsing across the star-speckled void. Routine protocol kicked in. Dishes in the United States, South Africa, and Chile trained their instruments on Proxima Centauri. Each one received the same distinct tone, always at the same frequency, always from the same patch of sky. Coincidence? Equipment glitch? The chances of global machines inventing identical data were next to impossible. The signal was a narrow-band transmission, so focused and isolated that, in all of nature, only a handful of phenomena could ever produce it. Fast-rotating neutron stars called pulsars? Maybe. But pulsar signals have a telltale rhythm, a cosmic drumming that rises and falls. This transmission was unbroken, almost artificial in its consistency. Researchers scoured datasets from years past, desperate to find a match. Nothing ordinary in the catalog of natural cosmic sources. Astronomers searched for possible Earth-based interference, radio traffic, satellites, even top-secret military operations. Nothing fit. It was more than just the frequency. The signal exhibited a level of mathematical symmetry. Subtle patterns embedded within the static. Sequences that repeated at intervals so regular, they hinted at intentional design. The deeper analysts dove, the stranger it became. News of the anomaly began to leak. Debates broke out among scientists. Was this evidence of something artificial, or just an unprecedented act of nature? Whatever the explanation, one fact was undeniable. The rules were being bent, maybe even broken. What if this signal wasn't just a random sound? What if, hidden in that relentless mathematical pulse, there was a message waiting to be heard? At first, the idea of intelligence felt almost too bold to say out loud. Scientists are trained to doubt, to dismantle mystery before declaring wonder. But as the data poured in, hour after hour, night after night, the question no one wanted to ask began to echo in every lab. Could this be something intelligent? Every ordinary explanation was tested and eliminated. Weather satellites? Ruled out. Ground interference? Impossible. The same signal was logged across independent hemispheres. Even reflections from deep space probes failed to align with the pattern. The signal was too clean, too patient, too deliberate. It didn't drift, it didn't distort. It behaved as though it had purpose. Within the SETI Institute and its global partners, whispers turned to structured analysis. They applied the WOW signal protocol, cross-verification over time, direction, and bandwidth. Each test brought the same unsettling result. Every observation aligned perfectly. No known natural source could reproduce it. That led to the next question. If it is artificial, who or what made it? Speculation fractured into possibilities. Some thought it might be a distant, automated beacon, perhaps long abandoned, endlessly transmitting a mathematical identity into the stars. Others imagined a civilization using binary tones to flag its presence, A simple but unmistakable "we exist." Still, others believed it might not even be meant for us. Maybe the signal was part of a network, a cosmic conversation between others, and we just happened to overhear it. SETI researchers reviewed the official protocols for first contact. The steps were clear: confirm, verify, and above all, remain silent until certainty is absolute. No response, no media release, no premature announcement. Humanity's next words to the cosmos would have to be precise and unified. But in the quiet corners of observatories and digital archives, scientists stared at that repeating frequency and felt something primal stir within them: wonder and fear. Because if the transmission truly was intelligent, then somewhere in the endless black sea of space, consciousness had bloomed again, and it had just reached out across 4.2 light years to say hello. And that simple possibility changed everything. This discovery was not a stroke of luck. It was the culmination of decades of relentless innovation. For years, astronomers dreamed of seeing deeper, hearing clearer, and now, with technology once thought impossible, that dream became reality. The heart of this breakthrough lies in phased array multiplexing. Imagine not just one powerful radio dish, but a whole global fleet. Hundreds of antennas from Australia to South Africa, Chile to California, each tuned with atomic precision, synchronized down to the millisecond. These telescopes do more than listen. They work as one, fusing their collected data to cut through the chaos of the universe. Older generations of radio arrays would have missed the faint signature from Proxima B, lost amid cosmic background noise, or overwhelmed by Earth's radio chatter. Now, new generations of instruments can filter, amplify, and isolate fragments of information never visible before. But it isn't just hardware. It's the software and the people behind it. Machine learning algorithms sift signals at unimaginable speed, recognizing patterns the human eye could never see. Scientists coordinate in real time across continents, verifying every anomaly, sharing instant updates, pushing the limits of what can be measured. The Global Telescope Network acts like a nervous system for our entire planet, responding instantly to the unknown. Together, it forms humanity's first true ear to the cosmos. And as we celebrate this unprecedented achievement, another question emerges. If this is what we can uncover now, what else might have slipped past us in the static of decades past? How many signals, how many greetings from the stars went unheard? Because our technology simply wasn't ready yet. The tools we've built have opened a crack in the universe, showing us there is still so much left to find. Once the signal was confirmed, a new challenge emerged, a puzzle decades in the making, deciphering something that might be from an intelligence beyond our understanding. Scientists and linguists from around the world gathered to comb through the data, looking not for words, but for patterns. They studied mathematical sequences, repetitive rhythms, geometric shapes embedded in the time intervals between pulses. Mathematics was the obvious candidate for a universal language. Prime numbers, Fibonacci sequences, and binary codes are not human inventions. They are cosmic constants. But even with these clues, cracking the code was daunting. Why? Because communication is more than math. It's culture, context, and meaning. How could a civilization light years away share a language with us? How could they overcome the vast differences in biology, perception, and experience? Researchers debated, could the message be based on physics, like atomic structures or molecular patterns, or fundamental constants of the universe, such as the hydrogen line known to all spacefaring civilizations? Speculation ran wild about the message's intent. Is it a simple "we are here," a greeting, a warning, or something more profound, an invitation to join a cosmic conversation. Decoding the signal became a task not just for scientists, but philosophers, poets, and cultural historians. What it represents is a bridge between worlds, calling humanity to think beyond itself. In every attempt to understand, we confront ourselves, our hopes, fears, and the fundamental desire to connect. The signal calls not only through space but through time, asking humanity to listen deeply and respond wisely. This endeavor has sparked a new era of interdisciplinary collaboration, blending the insights of quantum physicists, semioticians, and even cognitive scientists. The message challenges us to expand our very definition of language and intelligence, reminding us that the universe's mysteries demand not only technological breakthroughs, but profound shifts in human perspective. The cosmos may be indifferent, but the act of listening cultivates a hope that transcends distance and difference, forging a shared destiny with the stars. The discovery of a potential extraterrestrial signal does more than shake science. It sends ripples through every aspect of human life. This is a moment when our collective identity faces its greatest re-examination. Imagine humanity looking up to the stars and realizing that after millennia of solitude, we might finally share the universe with another form of intelligence. The cultural impact would be profound. Art, literature, philosophy, and religion would all seek new meaning in this revelation. Educational systems worldwide would change, integrating new cosmic perspectives that emphasize unity over division. Governments might increase funding for space exploration, technology, and international cooperation to prepare for what comes next. Ethical questions would thunder forward. How should we respond? What rights might we assume for alien life? Would this reshape our values or spark fresh debates about our role in the cosmos? History teaches us that paradigm shifts don't come quietly. Like the Copernican revolution or the moon landing, first contact would redefine our place not just on Earth, but in the entire universe. We stand at the edge of a new chapter, a chapter that transcends any one nation, belief, or ideology, reminding us that we are inhabitants of a tiny, fragile planet floating in the vast cosmic ocean. This moment invites both wonder and humility, urging us to be mindful stewards of the legacy we leave, not only for ourselves but for the generations who will follow on this extraordinary journey. And as we consider the vast unknown ahead, one question remains. Are we truly ready to accept that we are not alone? In recent years, our picture of the cosmos has rapidly evolved, shifting in ways few could have predicted. Powerful telescopes like the James Webb Space Telescope have revealed galaxies that are far older, more massive, and more complex than earlier models allowed. These discoveries have challenged our understanding of cosmic history, showing that the universe grew up differently than we once thought. Stars and galaxies formed faster, and black holes spun with unexpected intensity, breaking the neat equations that underpinned decades of astronomy. This accelerated cosmic evolution forces us to rethink the mechanisms behind the universe's formation and growth. We once believed the story of the cosmos was nearly settled, but instead, we've uncovered layers of complexity that no one anticipated. The signal from Proxima B arrives just as this revolution in knowledge unfolds, an emblem of how much there is left to explore and understand. Amid accelerating cosmic change, the universe no longer appears as a cold, static backdrop. Instead, it pulses with dynamism, alive with phenomena that push the boundaries of human comprehension. What we once regarded as immutable laws may only be chapters in a much larger, unfolding story. We thought we knew the universe, but it was humbling to discover we have barely begun to listen, and that the cosmos still holds secrets that could reshape everything we know. As our tools sharpen and our understanding deepens, each discovery reminds us how small our place is, and yet how extraordinary our opportunity remains to uncover the unknown. Beyond the vast expanse we can observe lies an even greater unknown, the unseen universe. What we detect with telescopes is only a fraction of what exists. The observable cosmos stretches billions of light years, yet beyond its borders, space may be infinite, filled with realms and realities forever out of reach. This unseen universe challenges our understanding of existence itself. Could there be infinite life, spanning dimensions and forms beyond human comprehension? Possibly entire civilizations, hidden not by distance, but by the very limits of what light and matter can reveal. This boundary between the knowable and the unknowable is humbling. It reminds us that despite all our technology, we might never fully grasp the cosmos. Yet, this very mystery fuels our relentless quest for knowledge. We search not because we expect certainty, but because in seeking, we affirm our place in a cosmos that is vast, mysterious, and endlessly compelling. As we stand on the brink of what could be the most profound discovery in human history, our gaze turns toward the future, toward new missions, new questions, and new horizons. Efforts are already underway to send probes and powerful instruments toward nearby star systems like Proxima B, hoping to gather clearer answers. These endeavors unite nations, scientists, and dreamers alike in a shared goal: to listen ever more closely and to understand a universe that has long kept its secrets well hidden. But this mission transcends technology. It's a mission to redefine what it means to be human, to embrace the unknown with courage and humility. The challenges ahead are immense. We must prepare not only scientifically, but ethically, socially, and philosophically. How will we respond if the signal turns into a conversation? What changes will ripple through our cultures, our beliefs, our identity? The stars have begun to speak. The universe is no longer silent. What we choose to do next could shape the destiny of generations yet unborn. But the story doesn't end here. There is much more to uncover, more mysteries to unravel, and truths waiting patiently in the dark. Are you ready to follow where this journey leads? Stay tuned, for the answers we seek may be closer and far stranger than we ever imagined.